Hello, everybody, and welcome to another episode of Advent of Code in Kotlin 2023 edition, I guess. Day 6. It is another day. It was time for another puzzle. We are starting, as you can tell, a little bit later than on the previous days, and we will return to our previous schedule starting again tomorrow. But of course, today we were slightly delayed by the fact that we had the AI launch event happening over on the JetBrains channel. Maybe you caught that. Either way, if you are tuning in today, and if you are currently in the chat, either on Twitch or on YouTube, make sure that you say hello. Maybe give a little wave, something like that. I already see the first couple of emojis popping in here. And of course, as usual, let us know what you thought of today's challenge. I'm very curious. I feel like there's I'm not sure, but I feel like there's a little bit of a pattern emerging in this year's Advent of Code, where it seems that every other challenge is slightly trickier, and then the pressure slightly lets off again on the next day. I'm not sure if that's intentional or if that's just my feeling. So make sure you let me know here. Have a lot of people coming in. Yeah, already have first people already exclaiming, today, trivial. Okay. All right. Well, then I hope if it was so trivial, maybe you even made a place on the leaderboard. Who knows, right? Thank you, everyone. Hello, everyone who is joining. Yeah. I had to say, personally, today I was quite delighted to find that the challenge, let's say, wasn't as time consuming as the prior days, because I did have a bunch of other things to do, and I had a couple of meetings that I really needed to get to. So it was kind of good having a little bit of breathing room here. Yeah. Maya also mentions that, I guess she has the same theory as I do, which is there's a difficulty pulse that matches uneven day numbers. Very interesting. Yeah. First day, I did not struggle at all to finish it. Of course, regardless, it's very cool that you check in here, you come hang out and spend your time with us, to still look at the solution, but also maybe to learn a little bit more about everything that surrounds Advent of Code. Doing it in Kotlin, doing it in all kinds of different ways. So today, I am very, very excited to have quite a special guest. If you're at all spending any time in our community, so if you're on the Kotlin Lang Slack in the Advent of Code channel, you may have already encountered some of their messages. You may have already seen them answer a couple of questions as well. And maybe you've already interacted in one way or another. And I think they're also the correct person to potentially answer the question, I wonder if there's an O of one solution. So I am really, really delighted to invite Femian to the show. Hey, how are you?
Hey, pretty good.
So
Good to be back.
Yeah, it's been a year, I guess. But you were on before. Do you still remember actually the puzzle that you solved on stream?
I believe it was the one where we were given a directory listing and we had to reconstruct the directory tree and do some calculation on sizes.
Right. Yeah, I do vaguely remember that. Man, there's been so many challenges in Advent of Code. It does tend to blur together a little bit. But yeah, for those people who don't know you, do you want to briefly introduce yourself?
Sure. So my day job is a Android engineer at a company called TripAdvisor. But I actually spend a good chunk of my free time doing, other fun things like more programming. Not only in Kotlin, although I do enjoy Kotlin a lot, but also a variety of other, well, both lower and higher level languages, I think. So I might get a slight sneak peek of that.
Interesting. Now I'm actually curious because I'll pull this up here again briefly on stream just for people. So we do have if you haven't checked out our blog post yet, we'll post this here. Herbert, by the way, describes you as nerd number one in Advent of Kotlin, which I think is that's a pretty high honor.
I mean, we have a lot of very skilled people in the community, so I'm definitely not carrying that alone, but I'm glad to be up there, I guess.
But yeah, so if you're not part of our community yet, make sure you do check out the blog post, which is also going to link you to our Slack community. And you are often active in there and also share your solutions. Personally, I'm always very delighted seeing those solutions there. They tend to have a certain elegance to them, and I'm hoping that even in today's slightly easier problem, we'll be able to see this. But I have had situations, I think like yesterday, where my solution ended up 170 lines of code.
Yeah, I understand. Sometimes it just spirals and spirals as you have to add more things to it to get it to work. But that's how it goes too, and in non-challenge code too sometimes, right?
Yeah. And at least for me, I mean, I'm always in a situation where I can't lose track of the goal, which is why I always leave myself breadcrumbs and a bunch of comments, at least when it comes to designing those algorithms. Yeah. So, but I'm actually, and then of course I go back into our community chat and I look at your solution and it's 30 lines, and I am curious, what is the secret?
Well, a good chunk of it is that I usually do clean up my solutions before I push them to GitHub. But also, as you might note if you're following my Git repository, I am solving every day in 4 different languages, which means I write a solution 4 times. And so in order to make that efficient, I do always have in my mind, what is an efficient short way to solve the puzzle. And so, that, yeah.
I guess we'll poke around your repo a little bit more in a little bit, but I'm just interested in this context. Do you have a background in competitive or sports programming, or is this something that you're just doing Advent of Code, or how does that happen?
I'm really just doing Advent of Code. I've tried competitive programming before, but I feel like it's not really for me. I don't know. I don't find all that much enjoyment in it, but Advent in general is a lot more community-oriented, as well as having a variety of more fun challenges with obviously very interesting stories tied to it that you get to enjoy too. So that's pretty nice.
Yeah. I have to say, and I think someone also mentioned this in chat a couple of days ago, was that one of the nice things about Advent of Code, potentially compared to just regular sports programming, is that there is a very large focus on community. There's zero judgment going on around how you solve something. It's about learning something new, which is really quite delightful. And I do enjoy that a lot myself as well, which is why we do this thing every year. So also there's a couple of more compliments here. Fabian's solutions are always so crisp and clear. And again, I think I can agree with this, which is why I've decided that we are going to slightly twist today's formula. We're gonna first go through my solutions, and then we'll see how nicely those clear up when I suppose you apply a couple more brain cells than what I'm capable of before I had my first coffee in the morning. So I think that's going to be quite interesting. I do wonder though. I feel like there's something there's a component maybe that I'm missing to become or to get the same kind of algorithmic prowess as you when it comes to problem solving. Is there a secret sauce? Is there, I don't know, is there like a maths PhD hiding somewhere, or like a physics like doctoral or something? Like,
No, there is not. I simply spent a lot of time just, playing around with things like this. I would say actually one thing that might be related is like back when Stack Overflow launched. This was, more than 10 years ago, I think. Oh, man, it's been a long time. I was very active there, and, it was a community where you could easily both pick up things that you saw and like barely understood, but could, then learn from other people's answers and then try to adapt it into your own knowledge and sort of bootstrap from there. And so I think part of it is from that, but a lot of it is really, so you can see these 4 languages in my repo, and they all bring different things to the table. And part of what helps, I think, is the fact that because they all have different things that are standard or typical in them, I end up thinking about, well, which one of these things would make sense in this other context, in this other language too? And it just brings sort of a lot more, options that you wouldn't think of otherwise, I think.
So, and we'll get into like the actual problem and its solution in a moment. But I'm sorry, I'm still just like a little gushing just a little bit here. When you solve a problem, like, so you're clearly like you're I assume you're doing this when the challenges come out, right?
Mm-hmm.
Yeah. And do you actually do you look at the problem statement and then you pick a language?
No, so in general, I go, so it's kind of funny. It just works out that I work in alphabetical order. So I usually do Haskell first, then Kotlin, then Python, then Rust. Partly because of what I feel comfortable with for building these things in. And so in Haskell, there's no order of operation really. It's all just thinking about what transformations am I making to the data as it passes through. And I feel like that helps clarify, what you actually need to do to solve the problem. But, for a couple of days, including today, well, today I did Kotlin first, specifically because I knew I was going to be on the show. So I'm like, I have to do Kotlin first. But also, sometimes it's also really convenient to just hack something together with regexes, which I can do in Haskell, but it's one of those things that actually is just a bit more ergonomic in Kotlin.
Yeah. I mean, this is very interesting to me because I've in university I've done a little bit of OCaml for a course, and that of course drills into you a little bit more of the specifically we were taught the camel part, excluding the O, the object oriented part of it, so that we would dive deeper into a functional language. But I just find that oftentimes when I look at the problems, or when I'm feeling the pressure of like I want to solve this right now, I'm like if I were just to sprinkle like a little mutability here or there, or maybe we'll we'll have something that's not entirely pure or not a great transformation, just a little loop over a range.
Right.
Yeah, those are the things where it's very tempting to fall back. So maybe some year I'll have to really get those skills cemented. Maybe I'll have to go for a purely functional language at some point as well.
Yeah.
Okay. Well, so I think it is time for us. The hat has been sitting over here, looking like mighty adventy. So I think it's time for a little bit of a dramatic reading, and then we'll see some delightful code that I'm sure we can discuss over for hours. No, I don't know. So, go in, and we will dive into day 6. Wait for it. The ferry quickly brings you across Island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here, but you don't see anything besides lots of water and the small island where the ferry has docked. As you try to figure out what to do next, you notice a poster on a wall near the ferry dock. Boat races, open to the public. Grand prize is an all-expenses paid trip to Desert Island. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. You manage to sign up as a competitor in the boat races just in time. The organizer explains that it's not really a traditional race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the farthest. As part of signing up, you get a sheet of paper, your puzzle input, that lists the time allowed for each race, and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go farther in each race than the current record holder. The organizers bring you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button counts against the total race time. You can only hold the button at the start of the race, and boats don't move until the button is released. For example, time is 7, 15, and 30. Distance is 9, 40, and 200. This document describes 3 races. The first race lasts 7 milliseconds. The record distance in this race is 9 millimeters. The second race lasts 15 milliseconds. The record distance in this race is 40 millimeters. The third race lasts 30 milliseconds. The record distance in this race is 200 millimeters. Your toy boat has a starting speed of 0 millimeters per millisecond. For each whole millisecond you spend at the beginning of the race holding down the button, the boat's speed increases by 1 millimeter per millisecond. So, because the first race lasts 7 milliseconds, you only have a few options. I think we're not going to go through all of those, but you can not hold the button at all, that is, hold it for 0 milliseconds at the start of the race. The boat won't move, it will have traveled 0 millimeters by the end of the race. You could hold the button for 1 millisecond at the start of the race, and then the boat will travel at a speed of 1 millimeter per millisecond for 6 milliseconds, reaching a total distance traveled of 6 millimeters. Hold the button for 2 milliseconds will give the boat a speed of 2. It will then get 5 milliseconds to move, reaching a total distance of 10 millimeters. Holding the button for 3 milliseconds means you have 4 milliseconds of travel time remaining, going 12 millimeters. 4 seconds is the same. With 5 milliseconds, the boat travels a total of 10 millimeters. With 6, a total of 6 millimeters. And if you hold the button for 7 milliseconds, that's the entire duration of the race. You never let go of the button. The boat can't move until you let go of the button. Please make sure you let go of the button so the boat gets to move. 0 millimeters. Since the current record for this race is at 9 millimeters, there are actually 4 different ways you could win. You could hold the button for 2, 3, 4, or 5 milliseconds at the start of the race. In the second race, you could hold the button for at least 4 milliseconds and at most 11 milliseconds and beat that record. A total of 8 different ways to win. In the third race, you could hold the button for at least 11 milliseconds and no more than 90 milliseconds and still beat the record, a total of 9 ways you could win. To see how much margin of error you have, determine the number of ways you can beat the record in each race. in this example, if you multiply these values together, you get 288. 4 times 8 times 9. Determine the number of ways you could beat the record in each race. What do you get if you multiply these numbers together? Okay, so we do have a professional here, so I do want to know what were you thinking when you read this description?
Well, I honestly kind of skipped down to the answers and worked backwards from there. So I was like, oh, so, you can go this distance. Where is that actually coming from? And so I was looking at that and realized it's, you're building up velocity, and then that gets multiplied by the time remaining. So that's what I did. I did go back to read the flavor text because it was fun, but right as the puzzle unlocked, I just skipped right to trying to figure out what the shortest thing I can do is. So
I think this is the pattern. This, weirdly enough, not only is this the pattern for a lot of people solving the problems, that they'll look at what the answer is, and then they'll collect the information they need to get to that answer. Weirdly enough, a lot of problems that we've seen this year also, there is some solution where the answer or the approach can be look at the input backwards, and you'll find an algorithm that might actually be more performant or easier to implement in that regard. Yeah. Cool. So we'll take a look at my solution first. And I decided my very first step was to look at the input. And the puzzle input is surprisingly short. There's only 4 races happening with distances that are all reasonably small. So I figured, okay, this is probably something where the naive approach of just checking all combinations of input values actually works. I did go one step further, because unlike with the previous examples, this table of inputs is transposed. So you have your time and your distance always below each other. I did the approach of manually just rewriting that
I mean,
input.
that's totally fair.
Yeah. I think so too. Well, you have a little bit of a spoiler up here for the second part. But yes, I quite literally just transposed these things manually, because this is 8 values. It's going to take me longer to find out. Some of them are 3 digits long. Some of them are 4 digits long. Do I do chunked? Do I do window? Do I do some kind of other split and then a zip? I could do it, but it was going to cost me two more minutes that I just wanted to save when push came to shove. Yes, and then in the original implementation, so this is the untouched implementation as I handed it in this morning for the first part. That's right. I decided, well, I still want to have some kind of data class of my races, and then I would just, because I transposed my input. My list of races is just that input, but we only look at the for the second part we would only look at the first line, and for the second part, for the first part we would look at the first 4 lines. We'd split those on the space and turn it into the actual values. And from there I just decided, okay, well, we'll have some kind of function that finds all the winning combinations. I was like, I can rewrite this using a standard library function. But for now, I'll just say, okay, I have a number of different ways of how long I can hold the button, and that determines my accumulated speed, which literally is just the time that I've spent here. And the time that is left for traveling is whatever is left over. That's just subtracted. The distance traveled is just my speed accumulated by my time left for traveling. I can print that because I'm very unsure whenever I code anything. So we have that in there. And then if the distance traveled is greater than the previous best of, I will just increase the counter. And then, you return that value, and all you do is you multiply all those values together again, which here I decided, all right, I'll go functional. We'll do a little bit of a fold operation here, which of course I could have also golfed slightly more by making this an int times reference. But I figured first we get the result, and then we make it nice.
Right.
Yeah. So this was just kind of like the first draft of what we had here. The obvious part is this could just be a count. This probably could just be an individual expression. Probably the whole thing could be inlined, and so on and so forth. I did not yet want to spend any brain power on figuring out a better or more performant solution before I took a look at part 2. But first, would you like to judge this solution?
I mean, no, I think this is totally reasonable given the size of our inputs. I didn't actually take a look at how big the inputs were before I started coding. And so I went with a much more general solution, which, helped with part 2, but it did slow down my times for part 1 by quite a bit. So I feel like given what we actually had, this is actually probably the fastest way. Like, it'll take, maybe a couple milliseconds longer to run, but it saves you minutes of writing time, right?
Yeah, so that's kind of where I was at. And Paul here says that line of code was so long, but it is just all chained operations, so I could just add a couple of line breaks here.
Yeah. It also looks longer in the ID because of those hints. Like,
oh yeah, I do love me some inlay hints. Those always add a little bit. But of course, if we wanted to, like, all of this could be slightly made a little bit shorter, and then it's not quite as scary. Obviously, we don't even need like an intermediate variable here. And then if you haven't watched the stream that we did with Dima on Monday, I believe, who is a master of all the like refactoring and moving these things around, make sure you take a look at that. Because his idea was actually, let's live code the solution. And I personally always think it's very impressive looking at that. Yeah. Simon mentions that the fold can be a reduce with int times. And I think that's also correct.
It can. The only thing that reduce fails at is if the list is empty, but it's not.
Yeah.
So
I guess in our case we don't. Look at that. We have a little bit of a code review going on here as well. So that's nice. And of course, so this down here should not be just having a variable and then returning it. But instead, we probably want to grab so we want to grab our range, and then we most likely just want to count based on the held milliseconds, whether that's greater than our initial value or not. And then at that point, we don't need to return anything else anymore. We can return that directly. That X goes away. This becomes an expression body if you want to, if that's something that you fancy. And then hopefully the indentation also looks slightly different. And of course, yeah, then this does not make the algorithm any faster, but if we do want to golf it a little bit, we could, of course, like inline this property, and then we'll inline this property, and we'll inline this property, and this all becomes a little bit shorter. And then I guess we inline the function. and I don't know how far, people want to take this reasonably. And I suppose you can take out this intermediate step, not assign it to anything. And this is the same solution, but now, for me personally, I need to look at this. I'm like, what on earth is going on here now? I do like me just a tiny sprinkle of abstraction if it helps with understandability. But apart from that, this is a transformation you can do. Yes. Now, of course, so here's actually, this is I'm curious. When you read the first part of this solution, or when you read the first part of the puzzle, did you in your mind have any anticipation for what part 2 might be?
Not at all.
Okay, all right.
Yeah.
Because I'm always like I'm like whenever I see like small numbers, I'm like something about this is pretty fishy.
Yeah.
Like something's gonna happen.
I was
Yeah.
sure we were going to reinterpret it somehow, but I did not have any clue how.
Yeah, like I was expecting this, like, oh, joke's on you, all these numbers are actually billions, or something like that. So yeah. Okay, so from there we move on to part 2. As the race is about to start, you realize the piece of paper with race times and record distances you got earlier actually just has very bad kerning. There's really only one race. Ignore the spaces between the numbers on each line. So the example from before, with times 7, 15, and 30, and distance 9, 40, and 200, now means time of 71,530 and a distance of 940,200. Now you have to figure out how many ways there are to win this single race. In this example, the race lasts for 71,530 milliseconds, and the record distance you need to beat is 940,200 millimeters. You can hold down the button anywhere from 14 to 71,516 milliseconds and beat the record. A total of 71,503 ways. How many ways can you beat the record in this one much longer race? And now that I reread this with a fresh mind and also having snuck a peek at other people's solutions, there is a little bit of a giveaway here that this is a continuous range. That these aren't like at some values it fails, at some values it doesn't. Yeah. So did you change your approach when you saw this?
No. So I went with a more complex solution at first because I didn't look at the size of the problem really. And so basically my part 1 just worked for part 2 except for having to deal with overflow. So
yeah. So pretty much this is the part which usually for me involves a bunch of praying. We'll go back to a solution that's slightly more readable again. Which is if the numbers become bigger, turn everything into longs and like cross your fingers and really, really hope that Santa like has a present for you, which is that it'll just work. And of course, since I'm manually transforming my input, this is a really important step that you can't forget. I now also had to transform the input manually for the second part in a different way. But yeah, once you've done that, the algorithm is like exactly the same. Now you only look at a single element. You map that out. You do the same thing, and all the calculations. Now you can see once again, thanks to all the inlay hints, you'll see there's a bunch of longs like just sprinkled all over the place. Yeah, and after that you just get an individual result, and I mean we'll see if I have broken my implementation prior to this recording, but we'll also see that even with an algorithm that tries all of the individual elements, this terminates practically immediately. And I was very happy about this because I was mentally, I steeled myself. I was like, okay, now comes the part where it's not just typing and not just trying and maybe more thinking. But I was spared that this morning, which is sometimes also nice. Yeah. But yeah, so nothing else really changed here. Yeah, Patrick says part 2 took 663 milliseconds. I feel like this one might be faster, but that might also just be based on my machine specs. Yeah. We also had a lot of people commenting beforehand, by the way, that the solution that was like refactored looks a lot more like the potentially initial solution that they had. And there was a lot of actually very interesting comments here, which is once you start inlining all of this, you kind of end up in code that's not self-documenting anymore. But of course, you can and have to use comments again in that scenario, which you probably wanted to avoid in the first place. So I think these are all quite
Well,
valid
I
points.
mean, I do feel like functional style doesn't mean that you can't have intermediate variables, right?
Yeah. No,
So
of course, of course. But having this, I would describe it as attempted golfed, like trying to minimize characters, is where it might like shoot you in the foot a little bit. Okay, but now I am very interested in seeing what your solution for the same problem was and what kind of potential optimizations I may have missed, how I may have approached this differently, and maybe we'll all come out the other side slightly better advent of code solvers. So I'm going to switch over to your screen here, and you can
all
walk
right.
us through that.
Well, this is basically what my code currently looks like after everything has been done. So, but yeah, for part one, well, so first there's number, which is a regex, which just grabs a string of digits. So all the digits in the substring before the first new line, so basically the first line, and I map them to long. So this is all of the times from the input. And there's the same, oops, wrong button. There's the same thing for all of the, whatchamacallit, all of the distances, right? This is a substring after the first new line, which is basically just the second line. Maybe it includes a trailing new line at the end of the file. It doesn't matter because I'm ignoring anything that's not a digit anyways. And so I'm zipping them together, which basically means if you have two lists and you zip them, you're taking them in parallel, which is exactly what we want here. And as I'm zipping them, I'm passing them into a function win count, which counts the number of wins. And then I'm floating with the, that little tidbit for, how to actually do a product, right?
Mm-hmm.
Like there's a sum helper in Kotlin. There isn't a product helper, extension function built into the standard library, which I kind of understand. It's way less used in reality, right? There's very few scenarios where.
That's true. I wonder actually what the return type on an empty list should be for a product.
I mean, I think in that case, like it's the identity of multiplication, which is one, right? The same reason that sum with nothing is zero, because
yeah.
Or yeah, I mean, if you think of it in terms of induction, right? If you have a list containing x and you take x out of it, then the sum should be x less.
Yeah.
Right. Same with multiplication. If you have a list of x, you take x out of it, it should be,
yeah,
divide by x.
No, I mean that makes sense conceptually and like rule based. The question is whether that is something that an average Kotlin programmer is going to expect.
Yeah.
But then again, if they find themselves in the situation where they do need to have a product, maybe they will,
Right.
or maybe we can just have a product or null.
That's true. Yeah, I mean, we don't have for example, we don't have a reduce or null. Reduce just throws an exception if the list is empty. But,
Yep.
That reduce or null, I don't know. Maybe that could be useful sometimes. But in any case, I think the other problem with product is that.
By the way, I have to correct you here really quickly. I just looked this up. Reduce or null is part of the standard library since
it is,
Kotlin 1.4.
Oh, okay. I need to reread the docs.
Hey, look at this. I'm glad I could have also, I was able to teach you something here.
Yeah. But no, I think the other problem with product is that it very quickly overflows, right? You have to have a lot of numbers in order to overflow sum. I mean, if you're working with normal scale things, but with product, 32 twos will get you out of the range of an int. So it's not really, yeah. But in any case, so I don't know. The parsing part is not that interesting aside from the fact that I basically did a hack to just look for all the digits, which is a very common thing that you can do in all of the advent of code problems, right? That's something that happens a lot. But the thing that we actually care about is how, given a time and a distance, how we actually find how many solutions there are. And so the first thing I noticed really is that the distance you travel is of this form, right? Where if you have x is how much time you held the button down for, time minus x is how much remaining time you have, and x is now your velocity because that was defined. So the distance you travel is that product, and you want it to be greater than that distance. And instead of looking up the quadratic formula, since this is a quadratic equation, instead of looking at the quadratic formula, I just did the multiply and stuff here, and just decided that these are the things I actually need. This is the window. This is how large my solution set is, and this is where the center of the solution set is. So that's really all I'm doing here. Is this is I did remember slightly the usual variable naming conventions in the quadratic formula, but so I have time divided by 2.0, which 2.0 is a floating point literal, so it's treated as a double here, and long divided by double, Kotlin treats it as if you did a 2 double. So that's exactly the same thing.
Huh.
I'm just
That's good
yeah.
to know.
And this is the other bit, same thing here. B is a double, so minus a long, it still is a double, so I can call square root on it. And then I actually had, here, let me, so originally I actually had some fancier code here because I had an issue with it, which only came up in the example and not in my actual input. But if this, if the square root is a perfect square, then you end up with these boundaries, your low point and your high point, are actually exactly equal. And according to the problem statement, you want to exclude that. You only want it when you exceed the distance, not when you equal the distance.
Okay.
So
so this is you moving to this is next double. This is
yes. This is next double and previous double.
Okay.
So
that is pretty scary.
yeah, I mean, so basically I know floating point representation well enough that I'm like, well, the next double, if I just treat it as an integer and I increment or decrement it, and then I, punt it back to a double, then it is the next or previous double. But afterwards I went back and I realized, yeah, I can just tweak where I'm doing my rounding and not have to, and take care of that. So that was my part 1, and that ended up being part 2 as well, but we'll see.
So you also started everything with longs right from the get-go?
I didn't. I had ints originally, but because the math in here is all on doubles, there was not very much to change. The difficult part, I wouldn't say difficult. The puzzling part was like, why am I getting a negative solution out of this? And realizing, oh, it's because this, this multiplication overflowed. Because originally I was doing the multiplication before turning it into a double. So I had int times int, which then turned into something very negative, and then that did not work out very well.
I see. So maybe for our viewers, and honestly for me, you can once again just go through the transformation the 3 transformation steps you did in your formula.
Yeah. So
Because
the first line.
I'm seeing you like so on the first
Okay.
okay, so because the first line does 2 things, right? Okay, so you pull the you multiply everything in your parentheses by x, and then you do times -1 on both sides. Is that correct?
Yes,
Okay.
that is correct. So I've expanded this product, and I've basically, instead of having, I've basically just turned this into the opposite. So
Yes, and I
then
do remember from some class that multiplying by a negative number does flip around the relationship.
right. And so here I'm just adding this bit to both sides to make it so that the left side is a perfect square. And then I'm taking the square root. Like I could have written, I guess.
Oh, okay. So you're expanding. Okay, gotcha.
Yeah. So square root of,
And that's because this is you can use like a binomial formula for that.
yeah.
Okay.
So square root of a square is, excuse me, absolute value. So basically that just says that, I can't stray away from the center point more than this amount.
Mm-hmm.
So
okay.
Basically, you could just take this and plug it straight into the quadratic formula, but I'm just gonna do this instead of remembering what it is.
Fair enough. Yeah, and of course the cool part about this is that then you determine like the entire win count at once. So you're now at 0-1, where I was at ON.
Right.
For each race specifically again. So yeah.
Yes. So you were O in basically the duration of the race.
Yes.
Yeah. And this is constant regardless.
So here's this is again first of all, I do like that, just I guess based on the comments, reminds of John Carmack's code in Quake. I assume this one was still maybe with the doubles and the fancy stuff, which no expletives in the code comments, so it can't be that bad. But that was, of course, the fast inverse square root. Of course, a classic there. Max says that apparently the double raw bit magic can also be done with number plus number.ulp.
Unit of in the last place. So going up it can, going down it almost always can, but it will get that wrong. In certain cases, unit in the last place is basically defined as the smallest epsilon that will take you to the next double. But at certain points, like at perfect powers of 2 in floating point, your step upwards and your step downwards are different sizes. So, like in practice, that would work, but it's not actually like 100% correct.
So. You know that after you answering this confidently, I have to ask, why do you have that information ready to go like this?
I don't know. I just found that thing. I learned how IEEE floats are laid out way back in college, and I found it pretty interesting. It's a set of engineering trade-offs, and so I've made use of it in various ways at different times.
Is it something that comes up like regularly outside of Advent of Code for you?
It doesn't come up very regularly, but occasionally. Like I remember way back working in a specific MapReduce framework that only allowed like sorting like binary Yeah, or string-like keys. But what I actually wanted to sort on were doubles. And so one of the thing I did then was to basically do exactly this. So I transformed the double into a string-like key by taking its binary representation that then sorts in exactly the right order. So things like that. I mean, it comes up very rarely, but it's one of those things I kind of enjoy. So you get to remember those.
I mean, I can't imagine that I suppose sticks with you in a certain way. And I do have to admit that sometimes the things where it also actually feels quite nice when a problem statement comes up and you immediately recognize it as like, oh, that's just like that thing that I did that one time ago in that very specific scenario.
Right.
Yeah. I believe before last year's Advent of Code, I had first read Bob Nystrom's Crafting Interpreters book, which is it has a bunch of information about interpreting and parsing stuff. And then when at some point one of the challenges was about parsing some kind of like recursive input. I was like, oh, wait a second. I have learned like just a couple weeks ago. I wrote a recursive descent parser. I can do this now. Yeah. So that's always a great time. Now, you haven't actually run this code yet, so I'm not even entirely sure whether this works.
Well, so one of the things that I do during development, which I actually did post during the somewhere in Slack before the contest, is I use Gradle to basically be my sort of immediate feedback. So Gradle has a T parameter for continuous, so which means it will retry whatever you do. So basically I tell it run the test, and then if that passes, then and so basically I'll do that and it'll build and run the test. The test didn't provide any output because it passed.
Mm-hmm.
But like, for example, if I intentionally broke this, right? Like that, then I come back here and it fails and, I get the feedback right away. And I'd actually have to open the file to see it, which of course opens in somewhere else, but, then you get to see the failure, what went wrong.
Yeah.
So, but that's what I do for my feedback. So I always have, so I take the test case, the example that is provided on the page, and I put it into a test file. And so every time I make a change while I'm working on the problem, I see right away whether the test passed or failed.
Okay. That's a pretty smooth way. It's almost like Kotlin notebooks where you hit them up.
Yeah, it's not quite as, of an immediate feedback as Kotlin notebooks, right? And Kotlin notebooks are amazing in that you get to see each little step along the way as well. Like whatever you want to look at, you just say, oh, val this, print, and show me what it is.
Yeah.
But whereas here, I'd actually have to basically do print line debugging. But
yeah, that's perfectly fine. I've heard of a lot of like, weirdly enough, I've talked to a lot of great engineers, and they're like, well, sometimes it's nothing beats sprinkling a couple of print lines in the code. No, this is awesome. So you obviously also do this in a couple of other languages, and we can talk about that in a moment still. But what you also mentioned, because I saw you specifically run a command here called JVM run.
Yes.
Which makes me feel like there might be something non-JVM also here.
There indeed are. So this repository is set up with Kotlin multi-platform targeting JVM. Actually, I can open up the build file might be not very helpful because if I look at the build file, I've actually separated things out into custom convention platforms, but you can see basically I'm targeting JVM, native, JavaScript, and WASM with a couple of special settings. So yeah, so the WASM I don't have set up to run directly, but all the others can run as just normal executables. So here, there's JVM run, there's run executable either Linux or Mac OS, and there's run the JS with Node. So I can copy this and take it into my terminal. And well, the JVM ran right away. It was already built. Linking the executables, native executables takes a little time. Link debug executable would be a lot faster, but I guess I could just actually change that.
So while this runs, what was the motivation for making this multi-platform?
Well, mostly I just wanted to see how well. I started doing this a couple of years ago, and I just started out being curious as to how well Kotlin really would work with multi-platform, because this is something that has been tried various times in the past, right? Scala also has a native target, for example, as well as a JavaScript target. And I don't feel like they had all that much success with it. But I was kind of more hopeful in Kotlin because, I felt that Kotlin makes a lot more useful and pragmatic decisions than Scala does. Like I used to have to program for Scala as well back at a previous job. And it's not a terrible language, but it's kind of like C++ in that there's a whole ton of junk that is thrown around as well that you don't need, but it's still cognitive overhead every time you're working with it. So anyways, so you can see, all of them run the same code and produce the same output, but they're all running in different ways. So that's that. And I actually
Are you evaluating these on any specific criteria, or like is it just like you'll make sure that all of them generate the same output, or?
Well, so last year I was using Kotlin X benchmark and comparing them. And at that time I thought it was pretty interesting that like native was actually, it was slower than JVM at throughput, faster startup, but slower at, running.
Yeah.
Because the JVM has had years and years of optimization, right?
I think this is what a lot of people say as well. Is like when you give it enough RAM, like the JVM can actually fly pretty quickly.
Like comparatively, native had caught up from like 2 years ago to 1 year ago, and JS was also like there are certain patterns that worked fast, but the JS code that Kotlin produces runs slowly.
Okay.
So I would have liked to set that up this year, but I'm using Kotlin 1.9.21, and the Kotlin X benchmark library doesn't work past like 1.9.0, so I can't actually use it properly. So like I can actually run, benchmark, but it's only running the JVM benchmarks because all of the others don't work at the moment, unfortunately.
Interesting. That's very curious to know, because our requirements only specify that it's supposed to be Kotlin 1.7.20 or higher. That sounds like something I should maybe check with someone.
No, I mean there's an issue. I think there's even open PR to like update it so that it does work. But
oh, great!
It's in progress.
Okay, well, as long as things are moving, it's already a good step in the right direction. Huh. Now I am curious. So after you've done, so these are just tests on JVM now?
Yes, these are just tests on JVM. I'm just measuring how fast each individual part of each day runs. So.
Okay. So after you've finished with your solution in Kotlin today, and I guess usually in your Haskell solution you move on to other languages. Is there
Right.
is there a language that you want to show off today where you're like, oh, it actually fits extremely well for this type of problem? Or
Well, I think this particular problem looks about the same in all of the languages. It's pretty, there's nothing that makes use of any real language features here. The only bit that I would say, I mean, we could take a look at, so for example, in Python, right? Aside from flipping the order around and the fact that they do have a product in the standard library, it's basically exactly the same thing. I'm using a zip, and I'm doing this on each result of the zip. And it looks different, but it's doing the same thing, right?
Yeah, I think there's a lot of if you look at the code, you there's a lot of, even with the all caps number, like you immediately, like your eye starts spotting a couple of patterns that are similar.
Yeah. And what else could I show you? I think my Rust code looks kind of horrific just because I'm not using regexes to pull out the numbers. I'm manually because I'm like, well, I can do this. There's no regexes in the Rust standard library, and I figured I can do this all in the standard library, and so I have to, grab all the digits on my own. But otherwise, it's really the same thing. It's just slightly more painful.
Yeah, it does have this is something that I've noticed in a couple of, like, I don't do a lot of Rust. I have downloaded Rust Rover a while ago, our new IDE for Rust, and I've played around with it a little bit, but I always find myself seeing a lot of like just like a little bit of boilerplate code because when you're doing collection transformations and maybe you're like running over an iterator and you want to clone the elements that are there, or it just transforms the original iterator, and all these kind of things. Yeah,
there's definitely a fair amount of noise introduced just because you have to deal with ownership, right?
Yeah.
It's not like, I think, depending on what you're doing, like it's a fair amount of, overhead, right? Like, or no, it's not like runtime overhead in terms of like looking at the code, right?
Sure.
You're explicitly telling the compiler, here I'm expecting that this is owned by somebody else and I'm just borrowing it, right?
Yeah.
But the fact that actually has to show up where it doesn't matter on JVM, right? Like everything is shared, and it doesn't matter if we lose track of who the owner is. Eventually, garbage collection will take care of it.
Yeah. Which I find at some points a little, it's a little easier to reason about. But I have to admit,
definitely.
I am always like peeking over there, just kind of checking out what's happening in the world of other languages as well.
Yeah, and I would say my Haskell solution, I definitely did golf this down a little bit. Like this is kind of the example of what you can do if you try to avoid binding any variables to anything. But I think it's not that bad because, like, for example, in part 2, right, this is how do I put this? Kind of it's just, once you learn how to read these symbols, it makes sense. It's like I'm doing.
I feel like that is one of the key aspects of Haskell, maybe.
True. Yeah. So, but sometimes the problem actually looks different. But not today.
So, but I'm curious if because you do have the 4 languages, and you said, well, problems do look different, and sometimes languages are like more suited to a problem, or they happen to fit better. And I'm curious, does each language have a type or category of problems that it does seem like extremely well suited for in like each of them?
Well, I wouldn't say that there's exactly a type of problem because it depends a lot on the details of the problem, right?
Mhm.
Like one of the things that, for example, out of all of these, I feel like Kotlin makes concurrency the easiest to deal with, which doesn't come up in Advent of Code very much, except we had, I
I
think,
mean,
one of the encode ones a couple years ago.
I mean, I'm gonna be honest. I mean, I did solve yesterday's problem with by just slapping a bunch of
I
coroutines on
mean,
top of things.
you can, but it's like how to put it, it's not necessary for any
Yes.
problem in Advent
Yeah.
of Code. Um, but you know, that actually I think works better in Kotlin than any of these other languages, right? Like Haskell does have its ways of doing concurrency, including some pretty amazing auto parallelization stuff if you can code to it properly. But figuring out what goes wrong in there is a bit tricky. Whereas it's actually pretty good, pretty easy to get well-performing code that, is also well understandable in Kotlin when you're doing concurrency. So.
Yeah, I personally think that, I mean, I have spent now a couple of months really like diving into the nitty gritty, and we've also given the workshops at the last Kotlin Conf, but I was quite delighted kind of throughout my whole journey of diving into coroutines, how what kind of API it gives you and what kind of concepts it introduces. It does seem rather well thought out. I will admit, it has a couple of like pitfalls and a couple of foot guns here and there that we probably could do with guiding people away from a little more directly. But I think overall the story is going in a pretty good direction.
Yeah.
Yeah. Wow. I mean, I feel like despite the problem today being rather short, I think we still saw and learned quite a lot today, which I think was really, really delightful. So thank you so much for that.
Yeah, and again, thank you for having me again. It's always great to talk about these things, and that's part of what makes the community on the Slack, the Advent of Code channel great too. Like people will just, I feel like I'm not as active this year as I have been before. I've dropped in occasionally, like just every day to post my solutions, but I haven't been as commenting on other people's solutions as I have as much before. I'll maybe try to do that more, but it's still great to see the ways that everybody approaches the problems. So.
Oh, totally. So if you're still not part of our community on Slack, I will once again link our blog post, which has the information on how to join. There is an Advent of Code channel where Femi and a bunch of other people, a lot of other people, are all coming together, posting their solutions, discussing things, and hanging out, having a good time, sharing hints, tips, helping each other debug, which is a really, really good time. And while you're already on the blog post, it's also very much worth, once again, looking into a couple of the other sections that are in here as well. Because we do have the leaderboards if you want to compete, or if you just want a chance to win a couple of prizes. You don't have to be the fastest one. As long as you are in one of those leaderboards and solved a couple of problems, you have the chance of winning some Advent of Code in Kotlin related prizes. We also have, of course, you can go back for the previous days and watch those, but we also have a couple of streams from last year also featuring Femian and a couple of other recurring guests, some of which you might still see in the coming days. You will have to tune in to find out. And of course, it also includes a couple of other information, including our template. Though I feel like if you're inside the Advent of Code ecosystem by now, you probably set up one of them. But this is always worth checking out afterwards. Wonderful. Yeah. Tomorrow we will return with another special guest who will once again come up with probably an entirely different view of the problem, and an entirely new and interesting story. Who knows? Maybe we'll even be in a different location. Will we? Oh, who knows? We'll see. We'll see how that goes. So if you do want to find out who and where tomorrow's stream is happening, you can just tune in at the regular time. So we're back to the regular schedule there, and I of course hope that I'll see a couple of you folks there again. Yeah. Apart from that, again, thank you so much for coming on. Really,
and
really.
Thank you very much too.
Yeah. And thank you to everybody who decided to spend their evening, lunchtime, mornings, or whatever time it may be with us, going through a couple of puzzles and hopefully learning something new about Kotlin. Take care, everybody, and hopefully see you tomorrow. Bye-bye.